All right. So this is 4.2 degrees in radians, video number 2. So this is talking about radians. So you probably remember from last time when we were talking about when we were using the calculator for um, calculating trig functions. I told you that it needs to be in degree mode. So it has to, on the calculator, it has to say DEG. Okay, otherwise it's going to be in radian mode, and radian mode is actually um, the units that we want when we're calculating um, uh, real life things, okay, real life situations. So when you go to chemistry, physics, you'll be calculating using radians instead of degrees, okay? Now, for the sake of geometry, degrees is fine, okay? Um, Here, a degree has no relationship to any linear measure, so you can't relate it to inches or degrees, or um, inches for each degree has no meaning. So the measuring angle that we use is radians. Okay, so radians is going to be um, it's going to be theta is equal to s, and s is going to be the arc length, and we're going to talk about that soon. So s is the arc length. Okay, arc length, and r is the radius of the circle. So from the center to the outside of the circle, that's the radius. Okay, and remember the radius is the same no matter where it is. These are all r. Okay, those are all r. And theta is going to be in degrees here. Sorry, in radians. So theta is the central angle. Okay, it's that angle there. So it's going to be the measurement of the angle is equal to the arc length divided by the radius. Theta equals S over R. Put that on notes. All right. And the central angle representing one full rotation counterclockwise about a vertex corresponds to an arc length equivalent to the circumference of the circle 2 pi r. From this, you can obtain the following radian measures. All right. So one rotation is going to be 2 pi r. Okay. And that's going to be equal to 2 pi radians. So 2 pi r divided by r. All right. And likewise, so here, and we'll see this on in the unit circle, which we'll see shortly. So the full circle is going to be 360 degrees or 2 pi. Okay, here, half the unit circle is going to be 180 degrees or pi. Here, a fourth of the circle is going to be 90 degrees or pi divided by 2. And here, this is going to be 60 degrees, and that's going to be pi divided by 3, pi thirds. Okay, which we'll see later, so don't worry. And there's going to be a whole unit circle that it's good to memorize. You'll see it and then you'll be able to memorize it later. Okay, if you want to memorize it, cool. If not, it's okay. I'll always have it on the notes, but it'd be a good thing to memorize it. All right. Now the thing is, we want to know how to convert from radians to degrees and vice versa, from degrees to radians. And you are going to use this a lot in chemistry. Okay. So whenever so you're either going to multiply by pi over 180 degrees. So pi radians, you don't really need to put radians and degrees. Yeah, you can. It'd be nice if you do, but you don't need to. Or you're going to multiply by its reciprocal, 180 degrees over pi radians. Okay, so when you convert to radians, sorry, convert degrees to radians, you're going to multiply the degrees by pi over 180. And theta is just like the angle. And when you're going to convert from radians to degrees, it's going to be 180 over pi. And the way I remember this is, I always think of this. Whatever you want should be on top. Whatever unit you want, do you want it to be in radians or do you want it to be in degrees? Whatever unit you want should be on top. Okay, should be in the numerator. So if it's radians that you want, then pi should be on top. Pi radians should be on top. If it's degrees that you want, then 180 degrees should be on top. So as long as you remember that, it should be fine. And remember, pi and 180 are equivalent to each other. Got some examples there. All right, so we're going to write each degree measure in radians as a multiple of pi and each radian measure in degrees. So this is going to be fairly simple. Let's do why don't you do number 10? Uh, okay, I know it's not an odd number, but try number 10. All right, and then I'm gonna do number 13. And then I want you to try number 14. I know it's not an odd number, I'm sorry. Why don't you try 15 then? Yeah, try 15 and I'll do 17. Okay. All right. So 13, remember whatever unit you want should be on top. So here I have degrees and I want to change it to the other unit, which is radians. So that means I'm going to multiply by pi radians because whatever I want, I need that to be on top. So I want the radians, so I need the pi on top over 180 degrees. So degrees cancels out. One is on top, one is on the bottom, cancels out. Okay, that's how you cancel out units. And you saw that in algebra 2 and algebra 1. You could do that again later. You'll see it later. Here you have negative 45. So how many times is 40? What goes into 45 and 180? Actually, 45 goes into 180. How many times? 4 times. And 45 goes into 45 once. So here we have negative 1 pi over 4. Or just negative pi over 4. That's 13. And then why don't you try 15? I don't know why I'm doing all negatives. Oh well, hopefully that's okay. So you're going to end up with positives because you have positive numbers. Okay, so just know that. I have negative 7 pi over 6. So I want to change this to degrees because this is radians. How do you know this is radians? Because we don't have the degree symbol. Okay, if you don't have the degree symbol, you know it's radians. No degree symbol means it is in radians. All right, so we have negative 7 pi over 6 times, and we want to multiply by, we want degrees, so we want the degrees on top. So it's 180 degrees, and we have pi radians. So the pi's cancel out, and here we're going to simplify. What number goes into 6 and 180? Actually, 6 goes into 180. 180 divided by 6 is 30, and 6 goes into 6 once. So we have negative 7 times 30. It's going to give us negative 210 degrees, and that's it. We have a 1 on the bottom, but we don't really, that doesn't matter. And that's it. All right, so try number 10 and number 15. Again, yours are going to be positive. All right, so now we're going to look at coterminal angles. So coterminal, co, together, terminal, it's like sections, okay? So it's like an airport. You have different terminals in the airport. So this is like quadrants. We have 4 quadrants, okay? So terminal is like the terminal side though, in this case. So the terminal side is in the same place, but it's a different angle. So this angle right here could be 60, but it could also be 420 degrees. Okay, how do you get 420 degrees? You do this. You go around once, so that's 360 plus that 60 here equals 420 degrees. Okay, so it could be either 60 degrees or it could be 420 degrees. Those are called coterminal angles. Angles that are different angles, but their terminal sides are the same. Initial and terminal sides are on the same spot. All right, so we have infinitely many coterminal angles, positive and negatives. Okay, so if alpha is another Greek letter, okay, for angles. So if alpha is the degree measure of an angle, then all angles measuring alpha plus 360 times n degrees, where n is an integer, are coterminal with alpha. So that means you can, like, let's say alpha was 10 degrees, all right? If you add 360 times 1, 360 times 1 is just 360, you get 370 degrees. So 10 degrees and 370 degrees are the same. Let's do times 10. right? Times 10 is going to be 3,600. That's going to be 3,610 degrees. Okay, this is also coterminal. Okay, it's in the same spot. You can also put negatives. Okay, so any integer. So that means positive and negative. So 10 degrees plus 360 times negative 2. All right, that's going to give us negative 720. So negative 720 plus 10 is going to give us negative 710 degrees. Okay, so remember negatives is going the other way. It's going clockwise. And that's denoted by beta, I guess. All right, over here. And then radians, remember what's the equivalent of 360 degrees in radians? 2 pi. So it's the same formula except we're saying 2 pi. So if we had pi over 2 is our alpha, and we're adding 2 pi times 1. So it's just going to be 2 times 2 is 4, plus the 1 is 5. That's going to be 5 pi. That's how you add a fraction in a whole number. So 5 pi over 2. You multiply the denominator and that whole number, and then you add it to the coefficient or the numerator there. Okay. So multiply, add, and the denominator should stay the same. So let's try it again. Let's do pi over 2, and let's do a negative. No, let's do a negative. 2 pi times negative 3. So it's going to be pi over 2 minus 6 pi. So here, again, multiply. 2 times negative 6 is going to give us negative 12 plus the 1 plus the numerator. So negative 12 plus 1 is going to give us negative 11. So negative 11 pi, and the denominator should stay the same, over 2. Okay, so these are coterminal as well. But that's okay. We're going to look at some examples, so don't worry. All right, so identify all. Notice how they say all. All angles that are coterminal with the given angle, then find and draw one positive and one negative angle. Coterminal with the given angle. Okay, let's do it. We're gonna end here after we do these. I'll do 2 of them, do 1 degrees and 1 radians. So I'll do 21. Why don't you do, why do I always do the negatives? All right, why don't you do a negative one? Do 19, I'll do 21. Okay, so negative 150 degrees. So you're either gonna add 360 degrees times n, or the angle plus 2 pi times n. So here I'm going to do negative 150 plus 360 n. And that's it. Ta-da! Those are all the coterminal angles. Now a positive one means we're just going to plug in a positive number for n there, if it becomes positive. But sometimes you have to do more. But I'll show you later. So I'm going to do negative 150 degrees plus 360 times 1. And that's going to give me 210 degrees. Ta-da! And a negative number, negative coterminal angle is negative 150 plus 360, and I'm going to use negative 1. So negative 360 plus negative 150 is going to give me negative 510 degrees. So one is positive, one is negative. That's what they want. All right, so I'll do 25. Why don't you do 22? Or did you want to do 23? Yeah, why don't you try 23? It's good practice. It's another negative. I'm sorry. All right. So 25, we have 3 pi over 2. And here this is radians. So radians, you just add 2 pi times n. That's it. That's easy. But now we need to do the positive. So if you do positive, we're going to have 3 pi over 2 plus 2 pi, and I'm just going to use 1. All right. And here you can do 2 times 2 is 4, plus 3 is going to be 7 pi over 2. Okay, so again, multiply the denominator with that whole number, and then add it to the numerator. So that's the quick way to do it. If you want to see the worked out way to do it, that's fine. So 2 pi, you want to get the common denominator, so 2 times 2 times 2 is going to give us 4. So that's the same as 4 pi over 2. And then you could just add the top. So 3 pi plus 4 pi is 7 pi over, and the denominators, you don't add them, they stay the same when you're adding and subtracting. When you're multiplying and dividing, then you change them. But here, adding and subtracting, they stay the same. There you go, 7 pi over 2. And then negative, do the same thing, but with a negative 1 plus 2 pi times negative 1. So we have 3 pi over 2 minus 4 pi over 2 is 3 minus 4 is negative 1 pi over. And don't add the denominators. There you go. Negative pi over 2. And that's it.